Greeting, ladies and gentlemen. Today's video I'm going to explain a little bit about pure substance. A pure substance, it is a fixed chemical composition through wood, and this is the example for the pure substance. We have a nitrogen and a gas in the air in the form of gas. Both of it is a pure substance because it have a fixed chemical composition. Pure substance also can exist in a combination about two or more another pure substance. For example, we have maybe in here that will be in the form of when there is in the air. For example, let's say that it is the air. We know that the air is consists of nitrogen, air is consists of oxygen. We still call it as a pure substance because the substance, the substance were homogeneous in condition of homogeneous. But we have another condition, which is you have a water and an oil. If you were combine it together, even though the oil it itself is a pure substance and the water itself is a pure substance, but we know but it is not a pure substance. The combination of it is not a pure substance because oil is not soluble in the water and it will collect on top of the water, forming two chemical dissimilar region. Pure substance also can occur in the combination of same element but in a different fast. For example, let's say that you are having breakfast in a cafe, you are order a glass of the water, and there is a combination in the water about liquid and ice. The combination of the liquid and ice were your substance if the ice were made from the water, the H2O molecule, and the water itself, it is an H2O. So even though the combination, one is in solid and the other there will be liquid, but if it is in same element, we call it as a pure substance. But let's say somehow you have a combination between a liquid and liquid in the molecule, they have a molecule about H2O molecule for liquid, and the air, it have a different molecule formula. We're not calling it as a pure substance. So that's all a little bit about the pure substance. We know that the pure substance can exist in three forms: solid, liquid, and the gas. Suppose you have a water in a room temperature, it will in the form of liquid. When you lower the temperature down to 0 degrees C at 1 atm, then the water will become ice. And if you held out the water into 100 degrees C at 1 atm at 101 kPa, it will become gas. But there is a situation where two phases of a pure substance coexist in the equilibrium. What I mean that there is a situation where, for example, water will exist in the both can exist in the form of liquid and gas in the same time. So to understand that behavior, suppose we make an experiment that have a piston cylinder device contain a liquid water. So you held up this water, let's say that the piston cylinder were in the confine, so there is no mess in and out of the control volume. So you held up this piston and the water were getting this energy, and this energy, according to the conservation of energy, will transform into kinetic energy, because conservation energy state that the energy can transform from one form into another. So this heat energy will transform to kinetic energy. Now the water molecule have an energy to move faster, so the volume will be increased and the temperature maybe will increase because there is a friction between the molecule and the wall container. But when it's reached 100 degrees C at 1 atm, you heat up this piston at 1 atm at 100 degrees C. The water will start to boil up. What happened essentially in here, it is the water were changing form into a gas. So this is where the situation, two phase of a pure substance coexist together, where the vapor and the liquid will exist at this process. That's why you have a 100 degrees C that constant for a certain period of time. It is because the heat and energy were absorbed by the liquid to break the force between the molecule, maybe a van der Waals molecule, I don't know. Need to the heat were absorbed by the molecule to break this bonding, this force between each other, so that they can change form from liquid into gas. In here, we call this process as saturated, the fast as saturated. So in this fast, we have saturated liquid and we have saturated vapor. Something in between, we call it as saturated mixture, whereas the saturated vapor and liquid will exist together. In here, you may be introduced by the X. X, it is the ratio of the mass for gas, water gas, in this case water gas, into the mass total. So that you will get the X, it is a humidity for the system. So when you continue this experiment, unfortunately, the temperature starting to rise up again. Maybe let's say that it will rise up to 300 degrees C. In here, all of the liquid has been changed form into vapor, and now when the temperature will rise up, all of it in the form of gas. In here, you may been introduced by PV equal to nRT. There is an equation for calculating the gas constant. For example, in here, if you can see, there is a table of thermodynamic, A2 table. If you go through to the very bottom of this list, you can see the steam. They have a formula for H2O. It is mean H2O can exist in the form of gas somewhere around this phase, and indeed at this phase. And it will have a gas constant about 0.4615 kilojoule per kg. K is referred to Kelvin. But if you times it by kg, you will get the universal gas constant, which is even though it is an air, argon, steam, propane, oxygen, you will have the same universal gas constant if you times it by their own mass. But anyway, this formula you will be introduced in this thermodynamic, PV equal to nRT, to find out the value for the gas constant, to find out the value of T, to find out the value of V, the value of pressure, but in the gas condition only. So this means this formula only can be applied on the gas fast only. You cannot apply in the saturated process, either in the compressed liquid process. Because the saturated process, there is a mixture between the gas and the liquid. So there is a sum of it were in the form of gas that can be applied by using this formula, but some of it cannot. So this equation only can be applied in this process, which is superheated vapor. So I think that's all for today. If you didn't have any advice for me. Oh, by the way, there is an experiment that been worked by the people, many people around of the world, and I don't know what is the exact type of experiment that they were working in, but this kind of experiment been worked by the pupil so that you will get your beloved table, thermodynamic table. If you go to the thermodynamic book, there is a lot of table A4, for example, A5, A6, A7, A8, being illustrated by this experiment. So I think that's all for today. Thank you for watching. If you didn't have any advice from me, I'm gladly accept it. So thank you for watching and have a nice day. Bye bye.